Hello and welcome back to yet another video lecture on design of flexible pavement. Earlier in the previous lecture, we have discussed about designing of the flexible pavement using CBR method, in which we use the CBR value of the soil subgrade in order to find out the total thickness above the soil subgrade. Now today we will go a little bit more further, in which we will see what are the types of design for flexible pavement and how to use the CBR chart as per IRC 37 2001, and also we will try to find out we will try to design a flexible pavement using some of the given data, and we'll discuss a particular solved example or problem. Now let us continue. So what are the general methods for design of flexible pavement? One method is empirical method, in which it is based on physical properties or strength parameters of soil sample. Then the next one is our semi-empirical or semi-theoretical methods, which is based on stress strain function and modified based on experience. Now, and next method is theoretical methods, in which it is based on theoretical analysis and mathematical computations. Now, these are some of the design methods that is used for flexible pavement design. Next, what are the design factors which is considered for design of a flexible pavement? Now, the first one is CBR value of the soil subgrade. Now, CBR value is very important for designing any flexible pavement. So now CBR test is to be carried out appropriately. So while carrying out CBR test, we should follow the norms and all the standards should be maintained, and the maximum or the worst moisture condition of the subgrade under actual site conditions should be taken into account, like when if there is a rainy day, or the place is affected by rain or the soaked conditions, and all those things has to be kept in mind while carrying out the CBR test. So the maximum or the worst condition of the subgrade under actual site conditions should be taken into account. The actual site conditions has to be kept in mind while carrying out the CBR test. Next, the top 500 mm of the subgrade for all major roads is to be compacted to a minimum of 97% of the density achieved by heavy compaction. The compaction should be at least 97% for the top 500 mm of subgrade. Then the CBR values, which is obviously represented in percentage, are considered consistent if the values do not vary more than 2 for CBR values 5 to 10. For CBR values 5 to 10, if it is not varying not more than 2% and not more than 3% for 11 to 30, it is considered as consistent. So the next factor is initial traffic. So this is one more very important factor that we consider it. And as far as the earlier method which I have discussed, in that particular method and a particular soft example, we did not consider the traffic values or the load from the traffic and all. So now today we are going to see how we used initial traffic value also. The traffic and the axle loads studies to be carried out during the feasibility studies and preparation of DPR, that is detailed project report. So during the studies for feasibility and during the preparation of DPR, the traffic and the axle load studies has to be implemented or has to be carried out. Now all heavy vehicles and commercial vehicles of gross load of 3 tons are considered. So while studying the traffic nature of the traffic and the load studies, the vehicle class that we consider should be of gross load value of at least 3 tons. Then axle load study is carried out on a minimum sample size of 20% of each classified vehicle class. So the axle sample size should be for the study of axle load, the sample size should be at least 20% for at least each classified vehicle class. Then different ranges of axle load data and number of axles per vehicles are grouped together. So for different axle load and for different number of axles per vehicle, it is segregated into different groups. Initial traffic N is taken as the estimated traffic after completion of the road construction and opening to the traffic. The value of the N, that is the initial traffic, is taken as the estimated traffic value which is after the completion of the road construction and when it is open to the traffic. So now let us move on to the next factor, that is design life. We represent it by small n. Here usually design life of 15 years for all different important highways such as national highways and state highways are considered. For state highways and national highways, the design life is usually for 15 years. For expressways, urban highways and sub-arterial roads, it is 20 years. In India, generally 10 to 15 years of design life is adopted for all other roads. For all other roads, rather than national highways, state highways, expressway, urban highways, generally 10 to 25% of design life is adopted. Now the next factor that we consider is the growth rate of the vehicles. So the traffic, how much growth it is going to have for each year, we have to consider it, and it is represented by small r. So it should be represented in terms of percentage. The average growth rate for each vehicle class is to be determined using past data and analysis. So the rise or the fall in the traffic or the number of vehicles or the rate of growth of the vehicle, we cannot just determine it arbitrarily. We have to do an analysis which should be based upon past data, like how much population is increasing and how much vehicular movement is going to occur and how much growth it is going to have. We need to have a study which should be based on past data, and we have to analyze it properly. The growth rate is to be taken into account for both during the initial period during construction and for during design life. So the growth should be considered for both during the initial period of the construction for the pavement and also for during the entire design life. So the next factor that we are going to consider is VDF value or EWLF value. Now VDF stands for vehicle damage factor, and EWLF stands for equivalent wheel load factor, which we have already solved a problem earlier in my previous lectures. Kindly go through it. So the axle loads and the number of standard axle per heavy vehicle are converted in terms of number of standard axle loads per vehicle, known as vehicle damage factor or VDF. So the axle loads which is going to be imparted by various number of vehicles has to be converted or has to be represented in terms of standard loads per vehicle, which is termed as vehicle damage factor. The value of standard load axle load is 8.16 or 8.17 tons, which we have already solved in one problem earlier, where we use the Ford power equation. The Ford power law is used under EWLF study. Obviously, I have already discussed this one earlier also. Then for commercial vehicle ranges 150 to 1500 per day. The VDF values are assumed as 3.5 on rolling terrain and plain terrain. The VDF values for commercial vehicle range from 150 to 1500 per day. For rolling terrain, it is assumed to be as 3.5, and for hilly terrain, it is assumed to be as 1.5. Next, for commercial vehicles more than 1500 per day, the vehicle damage factor values are assumed as 4.5 on rolling terrain and plain terrain and 2.5 on hilly terrain. For rolling and plain terrain, it is assumed as 4.5, and for hilly terrain, it is assumed at 2.5. So now in the next factor that we are going to discuss is about lane distribution factor, which is represented by capital D, or it may be represented by some other value in some other notes or in books. So the transverse distribution of heavy vehicles across the width of the carriageway along both the directions in case of two-way traffic movement is to be taken into account. So now the distribution factor for carriageway or for land distribution, it should be the movement of the vehicles across the width of the carriageway along both direction is to be taken into account. So this lane distribution factor, again we will see what are the guidelines on lane distribution factor value. So with this is again given by the IRC as per IRC norms. The first one is for undivided roads with single lane carriageway. The factor for lane distribution is considered as 1. For undivided roads with two lane carriageway, the factor is equals to 0.75. For undivided roads with 4-lane carriageway, it is taken as 0.40. For roads with divided carriageway with 2 lane each, so it is divided and it is 2 lane each, so the factor is taken as 0.75. So for roads with divided carriageway with 3 lane each, the value is taken as 0.60. For roads with divided carriageway with 4 lane each is taken as 0.45. So these are some of the values that we are going to adopt while calculating the design traffic value or the cumulative standard axle value. So this is a lane distribution factor which we need to have an idea, and if possible you have to keep this in your mind. Then next for let's see a particular problem in which we have to design a particular pavement. Design a new flexible pavement for 2-lane undivided carriageway using the following data. So now some data is going to be given, and in the question we have to design new flexible pavement for 2-lane undivided carriageway. It's already mentioned as 2-lane undivided carriageway. So according to our guidelines, we have to adopt a value for vehicle the lane distribution factor value as 0.75. So these are the data that they have given. Design CBR value of the subgrade. Again, the subgrade CBR value is given as 5% here. Then initial traffic on completion of the construction. So the initial traffic value is also given 300 commercial vehicles per day. CV means commercial vehicles per day. Then the average growth rate is also given as 6% per year. So per year the growth of the traffic will be in such a way that it's going to occur at 6% rate. So next is design life. The design life that we are going to design for the particular new flexible pavement is for 10 years. Then what is the vehicle damage factor? Vehicle damage factor is given as 2.5%. Now for solving this particular problem or designing the flexible pavement, we are going to adopt a process in which first we will find out the initial cumulative standard axle value for that computation for particular traffic, and based on that CSA value and the CBR of the subgrade, we are going to refer a particular chart which is termed as CBR chart, which again is derived from IRC 37/2001. So correspondingly in that particular chart we will be able to find out the thickness, total thickness of the pavement. So later later, after finding out the total thickness, we are going to see another catalog, which is the catalog for design of pavements, and it should be given for different traffic range, and in that particular catalog we will be able to find out what are the thickness of each layer. So I will show you that one later again. So now first let's see what are the steps there that we are going to uh, follow for designing this new particular flexible pavement. Now in the given data is such that CBR value of the subgrade is 5%. The initial completion, the initial traffic on completion of the construction of the road, that is nothing but your capital N. Then average growth rate, that is small r, is 6% or 0.06. Then design life is again small n, this is equals to 10 years. Then the VDF value F is equals to 2.5. The lane distribution factor is not given in the question, however it is mentioned that it is 2-lane and undivided road. So as per IFC, the recommended value for lane distribution factor for 2-lane undivided road is 0.75. So we are going to use this lane factor, capital D, equals to 0.75. Now let's see how to solve the problem. So now in the first process we are going to compute the design traffic. For the design traffic is computed in terms of cumulative standard axles per lane per day. So design CSA value for of different vehicle category is given by CSA equals to, this is the formula which we have again used earlier in one problem which I have already explained in previous video lecture. So now here's capital N is the initial traffic value, then the F is your vehicle damage factor, then D is your lane distribution factor, small r is your growth rate, and small n is your, here again it is given, small n is your design life and small r is your growth rate. So we have to know all these values, we have to substitute it, and we have to find the CSA value. Later on, for this particular CSA value and the CBR of the soil subgrade, we are going to use the design chart, CBR design chart. So now let's see what is CBR design. So CBR design chart for determination of total pavement thickness for traffic value with CSA of 1 to 10 MSA. If the CSA value is ranging from 1 to 10 MSA, the CBR chart looks like this. So in the x-axis they have given the CSA values, that is ranging from 1 to 10, and the total thickness value for the pavement is given in the y-axis, that is ranging from 200 to 900, and also correspondingly the curves are given for CBR values 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this is a particular design chart. The design chart is as per recommendations of IRC 37/2001. The design chart catalog is based on the result of analytical study of a study by Morth. So using the catalog we will find out the total thickness for traffic of different CSA values. Okay, then let's see another design chart which is similar to this one, but the range for the MSA values will be different. So again this is for the range 10 to 150. Here the CSA value range is from 10 to 150, and the pavement thickness range is from 400 to 1000. It is given. The CBR values are represented in terms of the curves, that is 2%, 3%, 4% till 10% is given. Same, it has been derived from IRC 37/2001 study by Morth, and we have to use this catalog for finding out the total thickness. Now after using this one we will have an idea about the total thickness, but what about the thickness for each layer? For finding out the thickness for each layer we will use another one, which is the pavement design catalog, recommended design for traffic range 1 to 10 MSA. Source is 37 IRC 37/2001. Now this chart is for CBR 4%. Let's see. Here the cumulative value of the MSA is also given. The cumulative value for the standard excels is given. There is 1 from 1 to 10, and in the second column it is given correspondingly the total pavement thickness is given. Then again the pavement composition, what are the compositions of the pavement, what should be each layer thickness is given again here. One is wearing course is given, then the next one is binding course, both are bituminous surfacing. Then in the next column it is given as granular base, where the granular base values are given here. Then again after that a granular sub base column is also given. This is particularly for CBR chart, for MSA, from MSA 1 to 10, and for CBR 4%. And in the next for MSA range of 1 to 10, and again the CBR value is for 5%. This is your again the catalog. So here again in the first column the cumulative standard excel value is given, then the thickness, then correspondingly using both the cumulative standard excel values and the total pavement thickness, we are going to find out the pavement composition thickness for each layer, So this is the way we are going to find out. Again, let's see another one for CBR value 6%. So this is for again for another CBR value for 6%. So we are having a catalog in which for different CBR values, and for MSA 1 to 10 we have been given with different catalogs. So all the thickness values will be different, and all the pavement composition thickness will be different. Now let's see how to use this one by actually designing a pavement from the data that we have been given. So design of flexible pavement, the first process that we are going to do is find out the design traffic, that is your CSA value in terms of cumulative standard excels. Now let's substitute the values of capital N, F, D, small r and n in this particular equation, and we will get it something like this. So we have 365 into 300 is your initial traffic. Then your vehicle damage factor VDF value is 2.5. Then your lane distribution factor is 0.75. So now the small r value, there is a growth rate is 6%, so 0.06. Then the design life is small n, that is your 10 years. So we will get a value of 2.7 MSA. Let us adopt 3% in order to let's round up to 3% so that we can have a we will find it a little bit easier for us to refer to the design chart. Therefore the design CSA value for the given traffic is 3 MSA, million standard axles. So now let's refer our CBR chart in order to find out the thickness. So this is a CBR chart in which your MSA values or the cumulative standard excel values for design traffic is given from 1 to 10. Then again the total thickness, the CSA value is given in x-axis, then your thickness is given in the y-axis, and the curves are there for different CBR values. For our particular problem we will follow the curve for 5% of the CBR, that is your 1 2 3 4th, your fourth curve coming from 2% of the CBR 2%. You have first 2% of CBR, second, third, 3%, 4%, 5%. So we will follow the curve for 5% of the CBR, and correspondingly we will check what is the MSA value. Our MSA value which we have taken is 3 million standard axles. So correspondingly we will refer our 3 MSA and we will come up to our 5% CBR, and we'll check out what is the thickness. Now for the CSA value of 3 and following the curve for CBR 5%, we will find out the value for total thickness in millimeters of the pavement, which is given in the y-axis. Now let's see. For here, the value of total thickness as per the design chart comes to be around 530. Now, how is it coming? Let me show you. Here is your 3%, 3 MSA. Now, let's come up to your CBR value, that is your 5% value. Then just refer it on the y axis in order to find out your this thing thickness. So it's comes up around 530 here. So this is the way that you are going to check the CBR chart. So now for the value of this total thickness 530 we will check the pavement design catalog for thickness of each layer. So now for the whole composition of the pavement, we will check what are the values for the thickness of each layer, each pavement composition. We will refer it in your design catalog. Pavement design catalog recommended design for traffic range of 1 to 10 MSA. Our source is 37 IRC 37 2001, and this is for your CBR of 5%. Again, keep in mind that you are going to have different types of catalogs. You should be able to know which one you have to use. You have to consider two main things, that is your CBR and your MSA value. Now this is your cumulative standard Excel value, first column. Then total pavement thickness, that is in millimeters. Now again in the third column it is bituminous surfacing. Then again you have the third column is wearing course column, then binder course column is also there, then granular base column is there, then granular sub base column is there. Now from the pavement design catalog, we will find out what are the values for different layers, namely granular sub base layer, then granular base layer, binder course, wearing course, or surface course, that we are going to find out from this particular catalog. Now in the problem, we have already calculated what is the value for CSA. Our CSA value was 3 MSA. So here is a 3 MSA. And our total pavement thickness according to that CSA and your CBR value was 530. Then we will see what is the thickness corresponding to these two values, both the values. What is the thickness? For granular sub base it is 230 mm. For granular base it is 250 mm. For binder course it is 50 mm. Then for your wearing course, that is 20 PC is your wearing course. Now here let's see how does the compositions look like. Now composition of the pavement components as per IRC guideline are as follows. For granular sub base you have 230, just now we have seen in our catalog. Then again for granular base it is 250 mm. Then again for the binder course or the BM is 50 mm. Then for the surface course or the wearing course is our 20 mm. Altogether it adds up to 530 mm, which is our total thickness of the pavement. Now this is the way you are going to design for a flexible pavement using your CBR value, your CSA value, the traffic loads are also considered, and your design life is there, then your growth rate is there. This is the way how you design using your CBR chart, and again by using your design catalog as per IRC 37 2001. I hope you all have understood how to design flexible pavement. So thank you everyone. Let's meet up in the next video.